Hello, good evening students. Today we have to see one more experiment in basic electrical engineering lab. That is one of the very important, that is 2 Wattmeter method. So measurement of 3-phase power by using 2 Wattmeter method. The electrical circuit diagram for 2 Wattmeter method for measurement of 3-phase power is as shown in figure. We have to take 3-phase supply provided in basic electrical engineering lab. Then through the fuse board we have to connect to the dimmerstat, that is 3-phase dimmerstat. Output of 3-phase dimmerstat is taken for further connection. Starting from R line goes to the ammeter of one point. Ammeter of second point goes to the wattmeter M point, and M and L, it represents current coil. It is internally connected in wattmeter. From L goes to one of the load, that is U1, star connected load. In star connected, U2, V2 and W2 are connected to form a common point because similar ends of the windings are joined. U1 is starting wind, U2 is finishing wind. All finishing end of the windings are joined to form a common point or star point, so it is also referred as neutral point. Then U1, V1, W1 is taken for further connections. Sir, Y line is given to directly V1 point, and similarly in B line is taken for again one more wattmeter W2, that is given to M point, and M and L are interconnected, that is of the current coil of wattmeter W2. Again you start from L goes to the W1, sir. So in wattmeter connection we have to give one more external connection from M and C. You give the connection from M to C, and C to V, again it is internally connected. It represents potential coil. So from external connection from V to Y line, both wattmeter voltage coil is given to Y line common point because Y is not consisting any wattmeter. After that you have to connect a 1 voltmeter between R line and Y line. After developing the circuit diagram, you make the suitable number of equipments required. So it is also referred as list of equipments or apparatus required. So from observing the circuit diagram, you go on making the list with their specifications. One is required 3-phase dimmerstat, that is of 440 volts 8 ampere. One is required. Ammeter, moving iron top 0 to 5 ampere bar 10 ampere. 1. Voltmeter 0 to 600 volts moving iron, and 1 voltmeter is required quantity. So wattmeter, that is unity power factor type UPF, with range 10 ampere 500 volts. We required 2 wattmeters. 3-phase resistive load, it may be star connected, it may be delta connect. We have to make the connection. Totally you can call 3-phase resistive load operating 5 ampere. One number is required. So number of connecting wires or patch cards, that may be rating of 10 ampere. Up to that, one set is required. After making list of apparatus required, then we have to go for procedure, brief procedure. The electrical connections are made as shown in circuit diagram. Then main supply is switched on with keeping certain positions, that is number 1 dimmerstat at 0 output position or minimum position, and 3-phase load in off position. Apply the suitable voltage by varying 3-phase dimmerstat. Take all the meter readings. The load is not applied still, so it is referred as no load reading. The loads are applied in suitable steps. At each step note down all meter readings. that is line voltage, line current and wattmeter readings are taken for every step. After conducting the experiments, once again before going to switch off, we have to remove the loads, that is step by step go on making switch off. Then you go for thermostat, applied voltage is brought back to 0 output position. After making this, then the main supply is switched off. Next important point is tabular column. What are the readings you are going to take for verification of your experiment, sir? So number 1, we want voltage, that is line voltage in volts, line current, it is printed as volts, it is not in volts, line current in ampere, wattmeter reading W1 in watts, wattmeter reading W2 in watts, total power W1 plus W2 by 2 wattmeter method, that is in watts. Then power factor by using the formula cos pi equal to root 3 W1 minus W2 divided by W1 plus W2. So you have to take one set or two set readings after conduction. During the conduction you have to enter the reading. So very important point is you have to calculate wattmeter constant. Then you multiply total wattmeter reading of W1, reading of wattmeter 80, multiplying factor is 2. So before conduction of experiment you have to calculate wattmeter constant by taking the range of meter we are using. So similarly W2 reads 70, its multiplying factor is also 2. So total power by 2 wattmeter method, that is W1 plus W2, 160 plus 140, you are going to get 300 watts. Lastly, we have to see specimen calculation. After taking the reading, you have to show one set of specimen calculation, how you are doing the calculations in your experiment, sir. So number 1, we have to calculate wattmeter constant multiplying factor for analog wattmeter. For that, voltage range of the wattmeter you are using, current range of the wattmeter, type of power factor, either least power factor or unity power factor. For unity power factor we have to take power factor as 1. For least power factor wattmeter, it is mentioned on wattmeter scale only, divided by maximum wattmeter reading. Don't confuse these voltage range, current range, power factor and maximum watt reading, all related to wattmeter only. Wattmeter, which type of wattmeter you are using, voltage range of wattmeter you are using, current range of wattmeter you are using, power factor of wattmeter you are using. So it is related to type of wattmeter only. After that you take wattmeter reading W1, actual reading into multiplying factor, wattmeter reading W2, actual wattmeter reading into multiplying factor. Number 4, total 3-phase power equal to W1 plus W2. Lastly, you have to calculate power factor, that is by using cos pi equal to we are using the expression tan phi equal to root 3 W1 plus W2 divided by W1 plus W2. You use that expression, that is once again tan phi equal to root 3 W1 minus W2 divided by W1 plus W2. From that expression you have to calculate phase angle. Phase angle equal to tan inverse of this value. So cos pi equal to cos of phase angle. So we are going to get power factor as unity because resistive load is 1. In resistive load phase angle is 0. Hence phase angle is 0, Naturally, power factor is 1. Thank you to one and all.